Hello, good afternoon, everybody. Today is March the 31st, and it's supposed to be a day off for observing Cesar Chavez Day. But I will take this time to go over one old test tool. This time I will get it from fall 2020. Please, no worry that I will not take attendance for today. Okay, because it's supposed to be a college day off, right? But at the same time, I feel like I want to take some time to record some review for your test tool, which will be for 2 weeks from now. So 2 weeks from now, you will have your test. I believe that's April the 14th is your test tool. Okay, now let's start. This is from fall 2020. Number one, there are 4 main blood groups, AB, B, and O, each with positive and negative races. Now, in the United States, the average distribution of blood types is as follows. We have O positive, O negative, B positive, B negative, A positive, A negative, AB positive, and AB negative. Now, part A, of 70 people, find the expected number of people with O positive. So the number of people is 70, okay? And then the proportion or percentage or probability of somebody have O positive is 38%, which is 0.38. Okay, so let X be, call that XA, be number of people have O positive, then the expected value number, the expected number of people with O positive among these 70 will be N times P. Which is okay, 70 times 0.38, 26.6. Now make sure you write the notation also though, okay? Either expectation of X subscript A or mu sub XA, like that. If you define your random variable as X subscript A, or you can just call that X also, I don't mind. Part B, of 60 people, so that's our N, N equals to 60 now. Find the standard deviation of number of people have a positive. A positive, but the notation is actually this is, yeah, I will take this as A positive. Okay, A positive will be 34% or 0.34. So if X subscript B is number of people have A positive, then the variance is NPQ 60 times P 0.34, and the Q will be 1 minus P. That will be 0.66. That's 60 times 0.34 times 0.66. That's 13.464. Now, however, what we need here is standard deviation, right? So I need to do the square root of that. Okay, so the standard deviation of the number of people with A positive will be square root of 13.464, which is 3.66933. If your decimal has more than 5 decimal places, then round it to at least 5 decimal places. Part C, find the probability that of 25 people, at least half of them have A negative. So probability of A negative, let's see, A negative, only 6%. 6%. That's 0.06. So let X subscript C be number of people have A negative. Then the probability that at least half of them, half of 25 is 12.5, right? Okay, but if you look at the list from 0, 1 to all the way to 12, 13, all the way to 25, right? Then more than at least 12.5 is actually start from 13, right? It actually starts from 13. Now then we will use the complement 1 minus the probability that the number of people with A negative is at most 12. Now, the reason I get at most 12 there is because when I see the all possible outcomes, the complement of at least 12.5, which means it starts from 13, is less than 12, less than equals to 12. Okay, and from there we will use, we will write down the calculator notation. That's binom CDF. The number of trials 25, probability of success 0.06 up to 12. That is 1 minus binom CDF 25.06 12. I get 0.99999. Oh, that's a long one. That's basically 1 if I round it to 5. Even if I round it to 7 decimal places, it's still 1. So the probability to have more than at least 12.5 people with A negative is 0. Okay, the probability is 0. Find the probability that any of 36 people, so you have 36 people, has AB negative. The probability to have AB negative is 1% or 0.01. Okay, so let X subscript D be number of people with have AB negative. Then probability that any of them, at least one, has AB negative will be the complement of nobody have AB negative. Then I use my calculator. That's 1 minus binom PDF. Okay, 36, 0.010. Now, I assume you know how to punch your calculator already. If not, then please take a look on my other lecture. Okay, to figure out how to punch that on your calculator. But it's basically second and then distribution and then binom PDF, binom CDF, so on and so forth. This is 0. So this is 0.30359. That's the probability. Part E. Find the usual interval for number of people having a positive. So the N equals to 60 and the P is 34% for A positive. Okay, so well, actually that's the same to XB, huh? Like XB, exactly the same because even the number of tiles the same. Okay, that's number of people have A positive. Now the mean is N times P. That's 20.4. And the standard deviation we computed earlier. That's 3.66933. Now then, to get the usual interval, we get the mean that the lower fence will be the mean minus twice standard deviation. And the upper fence will be the mean plus twice standard deviation. Okay, so minus 20.4 minus 2 times 3.66933. Okay, so the lower fence is 13.06134. And then this is 27.73866. So the usual interval, make sure you write it in interval notation. The usual interval will be, so if you have 60 people, right, and the number of people having A positive will be usually between 13 something to 27.73 something. Okay, that's the usual interval. So you can expect this many people with A positive. Okay, less than that or more than that will be quite unusual. Okay, that's for page 1. Notice that I did page 1 in only 12 minutes. Yeah, in only 12 minutes. Of course, when you are the one taking it, you may take much longer. The amount of time you spend for that question should be no more than the number of points for that question. So for example, the last question we have, number 1E, is supposed to take no more than 5 minutes. For this one question, number 1, it should not take more than 18 minutes. Okay, that's how you study. That's how you study. In reality, when you take the test, yeah, you may get slightly longer than that. Okay, the amount of time I give you is 120 minutes, right? Okay, so even if you do problems like 1 point for 1 minute, at the end, you still have approximately 15 minutes to check your work here and there. And of course, I strongly suggest you when you get the text, when you get the test, the first thing you do is like you flip through, have a feeling about that test. Okay. Now, don't just see this, oh, there are 6 pages. Oh, man, I need to go really fast. No, no. Okay. Because I give you a lot of space. I give you a lot of space. Okay. That's for page 1. Let's go on with page 2. Hyperbole lottery draws 4 regular numbers from 1 to 50. So we have that box from 1 to 50, 50 numbers in there. Now 4 of them correct means 46 of them wrong. And 2 hyperbole numbers from 1 to 20. From 1 to 20, the hyperbole, 2 of them correct, 18 of them wrong. Okay, now just use the notation, don't need to compute into decimal. Find the probability to correctly select only one hyperbole number only. Okay, so the hyperbole only one correct. Okay, but the rest are wrong. Okay, so I need to select 4 from the regular, or 4 of them wrong. Okay, and I need to select 2 hyperbole, only one of them correct, so the other one is wrong. Now, what is the probability? Okay, so probability that 0 regular and 1 hyper correct will be 4 choose 0 times 46 choose 4 over 50 choose 4 times 2 choose 1 times 18 choose 1 over 20 choose 2. Now, keep in mind, the way you write your combination notation has to be the C is capital C, and then those numbers to the left and to the right, okay, has to be subscript, smaller and lower. Don't write it this way. Don't write it this way. I don't like it, and that's not the correct notation, by the way. That's not the correct notation. Okay, this is not the correct notation. It's supposed to look like this. Okay, now that's the answer. And when you compute this, then you will get the probability of getting just one hyperbole number correctly and the rest are wrong. Okay, part B. Find the probability to correctly select 2 regular number. So let me redraw the boxes. This is 50 regular numbers, right? 4 of them correct and 46 of them wrong. Now you need to get 2 regular number correct, which means the other 2 is wrong. See, you need to select 4 regular numbers, right? Now, if 2 of them correct, then the other 2 must be wrong. Now, then the hyperbole, there are 20 hyperboles, right? 2 of them correct, the other 18 is wrong. Now, what you need here, both of the hyperboles should be correct. Means none of them wrong. Now, then probability to have 2 regular and 2 hyperbole correct, that's the probability notation, will be equals to, now this is the combinatorics notation. That's 4 choose 2 times 46 choose 2 over 50 choose 4 times 2 choose 2 times 18 choose 0 over 20 choose 2. Okay, that's for number 2. Now, I always have this question for my number 2, by the way. Always have this question for my number 2. Let's go on. Number 3. The following lists the probability distribution of X, the number of times a student absent in a 4 times a week class. So suppose our class is held every day, Monday to Thursday, then this is the distribution, that the number of probability distribution of a student absent in a 4 times a week class. Okay, now the question is find the mean and standard deviation of the number of X, the number of the number of times students absent in a 4 times a week class. Now, notice that the probability distribution given to us is not complete. Right? You need to complete that. One thing we know, the total probability has to be 1. Now, if that has to be 1, can you tell what number is supposed to be here? And then that must be something that add them up to 1, right? Which, if you think about it, 0.80 plus 0.10 plus 0.06 plus what equals to 1. Okay, do it on your scratch paper or just do the side. Then we solve equation 0.96 plus blah equals to 1. So blah is 1 minus 0.96. Okay, that's how we get that blah is 0.04. That's 0.04 here. Now, once we are done with the probability distribution, then we extend to find the mean and the standard deviation. Okay, let me erase this. P times x, and then x squared, and then px squared. This is 0, this is 0.10, 0.12, 0.12. When I multiply them, right? This times this, give me this. This times this, give me this. This times this, give me this. When I add them, I get 0.34. Actually, at this point, we can answer that first question already. Then the mean of x will be 0.34. Okay. Now then, how about x squared? I squared this, 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Then multiply by the corresponding probability. This guy times this guy give me this. This guy times this guy give me this. And so on and so forth. This guy times this guy give me this. This guy times this guy give me that. Okay? So this will be 0.10, 0.24, 0.36. And when I add, I get 0.70. So the variance of random variable x will be 0.70 minus 0.34 squared. I get 0.5844. Therefore, the standard deviation is the square root of 0.5844, which is 0.76446. Okay, now let me explain a little bit the breakdown of this numbering here. What are these 5 points? These 5 points is 2 points for this, 1 point for this, 1 point for this. Okay, and then 1 point for this, another 1 point for this. Okay, and then 1 point for this. Okay, those are the 5 points. Now, what is the 2 points here? First, you use the correct notation and the correct number. And what is this 4 points for the standard deviation? 1 point for this, 1 point for this, 1 point for standard deviation notation, and 1 point for the standard deviation computation. So when I give those numbers, there's a big chance that the number of points actually more than the amount of time you need to do the problems though. Okay, yeah, so when I say 5 points for this question, it should take more than less than 5 minutes for you to do. Okay, but I also have my breakdown when I give you 5 points for that. What are 5 things that I want to see? Okay, five things I want to see, or 6 things I want to see, but 2 of them small things. Okay, for example, I give half point for this. You need to write this correctly. Okay, but it's definitely 1 point here, 1 point here, 1 point here. So these 3 points so far. 1 point here, 1 point here, half point here. You know, okay. So that's for number 3. Oops. And that's the end of page 2, I believe. Let's go on to number 4. This one seems to be the hard one. A box contains 13 identical marbles, except in colors. Okay, 6 green, 4 yellow, and 3 red. Now, 3 marbles are selected at random with replacement. So you put it back. Now, find the probability of selecting any red marbles. At least one. Any means at least one. Probability that the number of red marbles is at least 1. Okay, now because we do it with replacement, then the probability of getting red the first time we select from this box is equals to the probability the second time, equals to the probability the third time. Notice that it basically forms a binomial distribution. Okay, so we can do it this way. This is equals to 1 minus probability that the number of red is equals to 0. And we use binom PDF. The number of trials is 3. Probability of getting a red is, like from this box here, what is, if you need to select one marble, what is the probability is red? And you will see there will be 3 out of 13. How do you get that, Thomas? There are 3 red marbles out of 13. Okay, 3 red marbles out of 13. Then that's 1 minus, then I use my calculator, binom PDF, 3 over 13, 0. I get 0.45517, which is 0.54483. That's the probability. Now, of course, in my test, don't just write the answer though. Don't just write this. Don't just write that. I need you to write the notation, probability notation and calculator notation if you do use that, and then get the numbers. Okay. Now, that's one way to do it, by the way. There's another way to do it. There's another way to do it. So this is method number 1. There's another way to do it is this. I need at least 1 red. And we know that's 1 minus probability of no red. Now, what is the probability you don't get red? Well, that's the same too. If you do it 1 by 1, 3 times, all of them not red. Okay. Now, what is the probability in your first choice? You get not a red, only this. Not red. They are 10 out of 13 not red. 10 out of 13 not red. Now, after you get something not red, you put it back. What is the probability? The second one also not red. What is the probability? The third one also not red. Okay, now when you compute, you will get exactly the same number. Okay, so in this case, you happen to be able to do it manually using the second method. Okay, now the first method will be the best. Okay, if I ask you find the probability of selecting 2 red marbles, then you can only use binomial distribution in this case. Okay, but if I say what is the probability of selecting any red marbles, then that's basically asking, can you find the probability of no red and subtract that from 1? Now part B. Part B, three marbles are selected at random, one at a time without replacement. Find the probability of getting red and then yellow and then green in that order. Then we do it one by one, right? Remember that there are 6 green, 4 yellow, 3 red, right? A total of 13. So what is the probability? The first one is red. It's 3 out of 13. Now, once you take one red out, because it is without replacement, right? Then there will be 6 green, 4 yellow, 2 red, right? After you pick one red out. Now then, what is the probability the second ball is yellow? That's 4 out of 12, because you took one red marble earlier, right? Okay, so after you get the yellow one out, then you get only 3 yellow left, 2 red left, and still 6 greens inside that box. Now, what is the probability? The last one is a green. There will be 6 out of 11. Okay, 6 out of 11. Then I use my calculator to compute this. I get 0.04195896. That's the probability to get red, yellow, then green in that order. Part C. 3 marbles are selected at random with replacement. With replacement makes it a binomial distribution. If the order doesn't matter though. Yeah, if the order doesn't matter, which they say it here, right? Okay, find the probability of getting at least 2 green marbles. Probability that the number of green is at least 2. Now, then that is 1 minus probability that the number of green is at most 1. Okay, there are actually 2 ways to do this. This is the first way. This is the first way. So the number of green marbles you may get are either 0 or 1 or 2 or 3, right? If you want at least 2 green marbles, that's the complement of at most 1, right? And that is 1 minus binom CDF. 3 trials, probability of getting green is 6 over 13 up to 1. Okay. Oh, hold on, Thomas. Why do you call that? How do we know that's binomial? How do we know that's binomial? Because of this, because you do it with replacement and the number of green marbles you get, you're only about the number of green marbles you get. Okay, regardless how you get it. You may get green, green, and then not green. You may get green, not green, green. You may get not green and then 2 greens after that. Okay, but we don't worry about the order. We just want to know how to get 2 greens, regardless how I get it. Okay, now then what happened? It's satisfied binomial experiment. Therefore, you can use binomial distribution. I use my calculator now. I get 1 minus 0.557578. So this is 8 here. It's 0.44242. This is a 4. Now, that's the first way. The second way, the second method, is doing it this way. Probability of at least 2 greens. You may do it this way. Oh, then that's the same to probability of getting 2 green plus probability of getting 3 greens. Now, it's feasible, it is okay to do it this way because there are only 2 things we need to compute, right? Okay, so it's okay if you want to do it this way. Okay, but if you have, let's say, at least 2 means, 2 and then 3 and then 4 and then 5 and then 6 and 7, like a lot of things you need to add, then you use binom CDF. But here, because you have only 2 events that are at least 2, then we can compute it one by one. This will be binom PDF. 3 trials. Probability of getting a greens is 6/13. You want 2 successes plus probability of 3 greens. Probability binom PDF. 3, 6/13, 3. Now then we use our calculator. I get 0.344105. That's 1 plus 0.098316. So that's 2 here. So when I add them, this is because of the rounding error. I get the same number, except because of the rounding error, I get 3 here. So it's supposed to be like this. It's supposed to be 0.6. Supposed to be 0.6 here. And it's supposed to be 1.6 here. Which when I add, it becomes 2.2. Right? You see what happens if we do too many rounding errors? Right? If we do too many times rounding error, compounded rounding error, we may get a slightly different number. Okay, but that's because of that rounding error. If you round to 5 decimal places here instead of 6 decimal places, then you will get 3 here instead. Okay, but those kind of little things, don't worry about it. Okay, don't worry about it. Try to avoid compounding rounding error as much as possible. Okay, but that's not something supposed to slow you down tremendously. No, just do it. You may lose half points for that if I think the way you do things is not reasonable. Okay, but as long as you round to 5 decimal places all the time, you should be fine. Okay. Part D, construct the probability distribution for the number of green marbles selected in a procedure of selecting 3 marbles without replacement. So let X be. We need to construct probability distribution. So we need to get the table. Okay, let X be number of green marbles selected. Now then, what are the possible value of this X? How many green marbles you possibly get if you select that 3 times? You may get no green, 1 or 2 or 3. Right? At most 3 because you only select 3. Okay. When we look at the box, we have 3 colors, but the consideration right now is only on green marbles. So we look at the green only. There are 6 green and how many not green? There are 7 not green. Right? Okay, 7 not green. Now, then what is the probability that the number of green is 0? You know what? For convenience, let's just use G. No, let's keep it X. I want to use G here, but I may get confused with that G that I used there. Okay, probability that x equals to 0 means I get nothing here. If no green, then how many not green? Remember that we need to select 3 marbles, right? If I need to select 3 marbles and none of them green, means the other 3 has to be not green. Okay, so then the probability will be 6 choose 0 times 7 choose 3 over the total 13 choose 3. Okay, now then we use calculator to compute this. 6 choose 0 is 1, 7 choose 3 is 35, and 12 choose 3, I don't know. 143, 286. Let me check. Yeah, 286. Okay, so we get 35 over 286. I don't think I can simplify that. Do not make it decimal. Do not make it decimal. Don't make it decimal. Just leave it like that. Okay, what is the probability that we get 1 green? To get 1 green means 1 green, then the other 2 not green, right? Okay, so the notation will be 6 choose 1 times 7 choose 2 over 13 choose 3. Now, 6 choose 1 is 6. 7 choose 2 is 21. Now you can use your calculator. Okay, 287. I mean 286 here. So when I multiply, I get 126 over 286. That's the probability of getting 1 green marbles if you select 3 marbles from these 13 marbles. Then what is the probability to get 2 green marbles? What is the probability to get 2 green marbles? To get 2 greens means how many not green? If we get 2 green, then the other one has to be from not green. Because we select a total of 3 marbles. I get 6 choose 2 times 7 choose 1 over 13 choose 3. 6 choose 2 will be 15. 7 choose 1 is 7 over 286. So the top will be 105 over 286. Now, finally, what is the probability to get the number of greens is 3? Means all greens, 6 choose 3 times 7 choose 0 over 13 choose 3. Now, 6 choose 3 is 20. 7 choose 0 is 1. So I get this is 20 over 287. Now, those are the probabilities only. Our main goal is to construct a probability distribution. So you need to summarize that in a probability distribution. Let me do it here. Okay, this is the outcome, the number of green. And this is the probability. For 0, the probability is, what's that again? 35 over 286. 35 over 286. For 1, the probability is, I happen to see it there, 126 over 286. Probability of 2 green marbles will be 105 over 286. And then probability of 3 green marbles will be 20 over 286. Now, don't forget you need to add them. Okay, you need to add them and make sure they add up to 1. Okay, so 35 plus 126 plus 105 plus 20 equals to what? You will see that's equals to 286 over 286, which is 1. That's what we need. Okay, therefore it forms a probability distribution. Okay, that's for page 3. Let me go on to page 4. Let me take a little break. My daughter is next to me and seems to need my attention. I'll be back maybe in 10 minutes. Okay, let's continue again. I think this is the first time you see in my test that I put in independent case. And all of a sudden you may think, oh, then this is new, it must be hard. Actually, no. I was trying to help students by making them independent. And I hope it becomes easier. But some students don't get it. Some students don't get it. Now, keep in mind, if event A and B are independent, okay, we use that perpendicular notation, then 3 things happens automatically. That is, probability of A to happen knowing B happen is equals to probability of A happen regardless anything about B. It's like knowing B happens doesn't tell us anything more or less about A. Likewise, probability of B given A is equals to probability of B regardless A. Okay, and probability of D intersection, therefore, is probability of A times probability of B. Okay, if 2 events are independent, this happens automatically. In fact, not only like A given B is probability of A, even if I put a complement here, probability of A knowing B does not happen is the same to probability of A. Okay, that's the good thing about being independent, right? You don't need to know what the other party is doing. Okay, now then what is the probability of A intersection B? Because A and B are independent, then it must be probability of the product of the probability. Okay, that's 0.2 times 0.25. That is 0.05. Okay, now this is not the case for all the time though. Like only if these 2 events are independent. In my other tests later on, you will see, I hope we encounter the case when A and B are not independent. Okay, A and B are not independent. And we know that A and B are not independent if, for example, I give you probability of A, let's say 0.2 in this case, and probability of A given B is, let's say 0.3. You see that if they are the same, then they are independent, right? Means A and B are independent. But because probability of A not knowing B happen or not is 0.2, while probability of A given B happen is different from 0.2, then we know for sure that A is not independent of B. Okay, now, but the case we have here is actually a lot easier because they are independent. So what? Then what is the probability of A given B? Well, they're independent, so it's the same to probability of A, which is 0.2. Right? Okay, how about probability of the union? Then this is probability of A plus probability of B minus probability of the intersection. The inclusion-exclusion formula. Okay, that's 0.2 plus 0.25 minus 0.05. By the way, I get this from part A. That is 0.40. What is the probability of A intersection not B? That's probability of A minus probability of D intersection. Probability of A is 0.2, probability of D intersection is 0.05, so the difference is 0.15. Okay, now what is the probability of A given not B? Again, because A and B are independent, then probability of A knowing B does not happen is the same to probability of A only, that is 0.2. Okay, now you may want to do it slightly longer, okay, using formula. That's the first method. The second method, the one we usually use in class, probability of A given not B is probability of A intersect not B over probability of not B, right? A intersect not B, that's from part D, that's 0.15. Probability of not B is 1 minus 0.25. Probability of B is 0.25. And this is 0.15 over 0.75. When you use calculator, you get 0.2. Okay, so you can do it long way, you can do it short way. I believe you prefer the short one. Okay, then next question, number 5, Poisson distribution. At a grocery store, the number of customers arriving at the checkout line follows Poisson distribution with a rate of 2.4 customers in 4 minutes. So let X be, maybe let X be number of customers. Now, X is Poisson distributed with average 2.4 in 4 minutes, right? Okay, now then, part A, find the probability that at most 4 arrivals in 4 minutes. So the number of people coming in is at most 4 in 4 minutes. Now make sure the average that you have is also in 4 minutes. Okay, if the period is 4 minutes, then this has to be in 4 minutes. Then you can use that average. Okay, in this case, the average is 2.4, right? Okay, so calculator notation, Poisson CDF. The average in 4 minutes is 2.4. You want at most 4. Then you use your calculator. (2.4, 4). Oops, what am I doing? I get 0.90413. Okay, that's the probability. Now keep in mind that I need you to write the probability notation. Okay, and then calculator notation, and then the calculator result. Okay, I want you to write the probability notation and then calculator notation and then the result. Now, part B, at least 5 arrivals in 8-minute period, an 8-minute period. Oh, so this is not 4 minutes anymore. I need to adjust my distribution. It was originally Poisson with 2.4 for 4 minutes, in 4 minutes. So what will be the average in 8 minutes? Multiply by 2, right? Actually, you may prefer to make it into 1 minute first. So 1 minute is 0.6, right? Okay, so 8 minutes will be 0.6 times 8. Okay, so probability that the number of arrivals is at least 5. At least 5, either 5 or more. At least 5. That's the complement of at most 4. That is 1 minus Poisson CDF. Okay, 4.8. That 4.8 comes from here. That's the average for 8 minutes. Up to 4. So Poisson CDF 4.8 is the average or lambda up to 4 successes. That's 1 minus 0.47626 is 0.52374. Okay. Next one, find the probability no arrival in the next 1 minute. In the next 1 minute. So then X will be Poisson distributed. That's 2.4 in 4 minutes, right? So in 1 minute, it will be 2.4 divided by 4. 0.6. Okay, probability that no arrival in the next 1 minute because I need to go to restroom, let's say. So what is the probability I go to restroom just to wash my hand for 1 minute, come back, and nobody shows up and I don't get caught? That will be Poisson PDF 0.6, 0. That 0.6 comes from here. Okay. That's Poisson PDF 0.60. The probability is 0.54881. So more than half of the chance, more than almost 55% chance that you can go for 1 minute, come back, and nobody's there yet. Okay, that's for page number 4. Usually I put this question on Poisson distribution as my last question. In my older tests, I usually put this Poisson distribution as my last question because that's the last topic of our class, right? But I put it kind of in the middle of the test here. It's simply because of the placement purpose. Okay, I mean, I try to write it in a way that you have enough space, but at the same time, I don't want to give you too many space that you get scared, like, oh, Thomas test 2 hours, but 8 pages. No, I don't want that. I mean, it will create unnecessary psychological burden on you. Yeah, it gives you a pressure that, oh, 8 pages, only 2 minutes, then I don't have enough time. Well, actually, no. So I rearranged the position of this question. Instead of the last question in the test, I put it in the middle so that I can fit them into 6 pages. Otherwise, it becomes 7 pages or 8 pages. Okay. Now, number 7, the one that you see very, very often. The following Venn diagram describes the number of elements in A, B, and C. Now, just use the notation, do not compute into decimal. Now, suppose 5 different elements are 5 different elements. Is repetition allowed? The answer is no, repetition is not allowed. Right? Because if repetition is allowed, you possibly select the same element again. Okay, again, let me say it again. If I say suppose 5 elements or 5 different elements, it means it is without repetition. Okay, it means it is without repetition. Okay, why? Because if it is with repetition, it means you may do it 5 times and you end up with the same result, with the same element, which we don't want. Okay, so these 5 different elements, or simply say 5 elements, implies that it is without repetition. Okay, now suppose 5 different elements are randomly selected from the diagram. Find the probability at least one of them from C. Oh, then I guess I need to find out first how many elements we have in total here. How many elements we have in total here? It's 9 plus 7 plus 2 plus 10 plus 1 plus 2 plus 3 plus 6. 18, 28, 31, 40. There are 40 elements. And how many elements in C? Number of elements in C is 10 plus 2 plus 2 plus 3. There are 17. So the probability that at least one from C will be 1 minus probability no C. Okay, all of them from outside of C. Now, how many no C? It's 23, right? 40 minus 17. So 1 minus, what is the probability? The first one is not C. That's 23 over 40. Probability the second one not C. That's 22 over 39. And you do it 5 times, right? And that's it. Just leave it like that. Why? Because I say just use notation. Do not need to compute that to decimal. Now, that's the first way to do it. The second way to do it is at least one is 1 minus probability of no C. Now we look at that way. Imagine that Venn diagram now becomes 17C and 23 not C. Now, what is the probability you get nothing from here and all 5 from here? That would be 1 minus 17 choose 0 times 23 choose 5 over 40 choose 5. Okay, either one of them is okay. Now, both of these will give you the same answer. Both of these are the same answer. Okay, now part B. What is the probability that only one of them from A? Probability that A equals to 1. So we will break it up this way. We want to find out how many A's, how many not A's. Is it okay? And later on, we'll choose one from here, which means the other 4 should be from here. Do you see that plan? Now let's see how many A's. Number of elements in A will be 7 plus 2 plus 2 plus 1, that's 12. Okay, so the number of elements not in A will be 40 minus 12, that's 28. That's 12 here, 28 here. So 12 choose 1 times 28 choose 4 over 40 choose 5. Now, other than this method, there's actually one more method to do this with if you don't want to use combinations. Okay, but it will be quite difficult to understand. That's why I don't want to do it. That's why I don't want to use that other method. Now, some students during the tests in the fall, however, I think 1 or 2 of them actually use that method. They wrote the notation, okay, but they'll make a little mistake here and there. You know, they get the idea. Okay, I want to do it this way. Basically, that person think this way. That person think this way. The probability of 1A means you have 1A. What is the probability to get A? And then not A 4 times. Okay. And then this person realized that there are actually 5 ways to get 1A. So plus probability that the A actually happens at the 3rd place. Plus probability the A happens at the 4th place. Plus the probability that A happens on the last place. And that person compute the probability for each one of them. Probability that you get A first, that's 12 over 40. And then not A, that's 28 over 39, 27 over 38, 26 over 37, 25 over 36. And then plus, do the same thing again. And yes, eventually that person just get confused. Okay. I'm not saying the work is wrong. So I give that person partial points, but it's just like, that's, if you compute it that way, and I ask you to select 10 different elements, then you will have mental breakdown. Okay. No, I don't think that's how you want to do it. Though. At that time, I still accept that, but it's actually not a good approach. Part C, find the probability that the first 2 are from B. Oh, the order is important here, huh? So probability that you get B twice and the rest are not B's. So the order is important here. Hey, just do it one by one. How many B's, by the way? 1 plus 6 plus 2 plus 3, also 12. Okay, so 28 not B's, right? Now, what is the probability? The first one is B, 12 over 40. What is the probability the next one also B? That's 11 over 39. What is the probability the next one not B? There are 28 not B's out of only 38 marbles left, or 38 items left. And then 27 over 37, 26 over 36. And that's it. Okay, now somebody else may say, Thomas, I see it this way. The order is important. So 12 permutes 2, and then 28 permutes 3 over 40 permutes 5. That's also acceptable. In fact, that's the better one. Yeah, you use permutation if the order is important. Okay, now, so, but Thomas, what is the reason you don't want us to go to decimal? It just takes more time. Okay, I don't really need to check your calculator ability because I already checked that earlier, you know, in other questions, right? In other question here, like part E, I already checked your ability to compute combinations. Okay? If you know combinations, I can assume very well that your permutation will be fine, right? It's more about, do you know how to use them right now? When to use them, how to use them, so that you get what you want without showing too much work. Okay, Now that's for page 5, I believe. Now the last question. Is it the last question? I think this is the last question. A game of 3 tins, draw 3 cans of soda without replacement. From a box of 12 identical cans, except in brand, Sprite, Coke, and Fanta. Now, you will select 3 cans, right? Now, then you will get $10 if all of them Sprite, $40 if all of them Coke, $100 if all are Fanta, and $200 if you have Sprite, Coke, Fanta in that order. And you lose $5 otherwise. Lose $5 otherwise. What is the probability? Well, let's take a look later on. Okay, now construct the probability distribution of the payout, which means you need to compute the probability for each payout. And then you construct the probability distribution. And then you compute the expectation and standard deviation. Okay, let's work it out. We start from defining a random variable. Let x be the payout. What are the possible values for x? You may get $10 or $40, $100, $200, or you lose $5, right? Okay, now, what is the probability that you get $10? You get $10 if all Sprite. There are 12 cans, right? 5 of them Sprite, the other 7 not Sprite. Now, for you to get all Sprite means 3 of them Sprite and none of them not Sprite. And the probability will be 5 choose 3 times 7 choose 0 over 12 choose 3. That's 10 times 1 over, what is 12 choose 3? 220? Yeah, 220. So the probability is 10 over 220. Now, how about the probability of getting $40? That is if you get all Coke. Right? Now let's see the box. The box has 4 Coke and therefore 8 not Coke. You need to get 3 from here and of course nothing from here because you only select 3 cans of soda. The probability will be 4 choose 3 times 8 choose 0 over 12 choose 3. 4 choose 3 is 4. So this is 4 over 220. That's the probability of selecting all Coke such that you will get $40. What is the probability you get $100 instead? That's if all of them Fanta. Okay, but we have only 3 Fanta. Therefore, the rest of 9 not Fanta. And you need 3, all 3 Fanta means none of them not Fanta. 3 choose 3 times 9 choose 0 over 12 choose 3. That's 1 times 1 over 220. That's 1 over 220. Seeing this, I know that later on I cannot reduce because the smallest number I have right now is already 1. I will not be able to reduce this fraction, but I will keep them in fraction. Okay, especially I said it here. If you change them to decimal, then you will have too much rounding error. Yeah, you will have a lot of rounding error. No, don't do that. Okay, don't do that. Let me continue. You will get $200 if you get Sprite, Coke, Fanta in that order. Okay, let's see. What is the probability you get Sprite first? There are 5 Sprite out of 12. Now, after you get that can out, what is the probability? The second one is Coke. It's 4 out of only 11 tins left. And what is the probability? The next one is Fanta. There are only 3 Fanta out of 10 at that time. Okay, so I will get 1 over, this is, maybe I compute this first. This will be, I want to do this. I want to do cross cancel. This will cancel the 12, right? That will cancel the 12. And I cancel this by 5, so I get 2. So I get 1 over 22. Is it okay? On the top, I get 1 times 1 times 1. And the bottom, I get 1 times 11 times 2. Okay. Now, you can also just multiply them first and then reduce using your calculator, which I taught you before how to do. So this is 60 over 120, 1320, reduce the 10, reduce by 6, but I need over 220, right? 10 over 220. That's the probability of getting $200. So what about the probability of losing, Thomas, losing $5? There are so many ways to lose, right? There are so many ways to lose. But we know the total has to be 1. So let's just do it this way. This is 1 minus the probability of all. Probability that x equals to 10 plus probability that x equals to 40 plus probability that x equals to 100 plus probability that x equals to 200. Okay, so 1 minus the probability from here, the sum of this. Okay, in other words, if I add all those probabilities where I won, when you win, then that will be 10 over 220 plus 4 over 220 plus 1 over 220 plus 10 over 220. That is 1 minus 25 over 220. That's 95 over 220. That's the probability of losing $5 instead. Now, there's no other payout. So we are done basically with computing the probabilities. What we will do next is to set up the probability distribution. And we need to extend that later on. So let me just make it long enough. Okay, let me make it long enough. So this is our x. There are 10, 40, 100, 200, -5. Those are the possible outcomes. Or the probability is 10 over 220, 4 over 220, 1 over 220, 10 over 220, and 95 over 220. The total is supposed to be 220 over 220, which is 1. Next. Then I will extend this to get the px, right? I think this is way too long. Give me a second. So P times X, 10 times 10 is 100 over 220. 40 times 4 is 160 over 220. 100 times 1 is 100 over 220. Now this is 2000 over 220. And I wonder what will this be? 5 times 95. 475, right? For negative 475 over 220. Now then you add all of this. 100 plus 160 plus 100 plus 2000 minus 475. I get 1885 over 220. So let me write it aside here. The expected value of the payout, the expected payout will be 1885 over 220. That is 8.56818. And that is a positive expected value. Means if you keep on playing these games, on average, you will win, because this is positive 8, right? You will win on average of $8.567 per game on average. So if somebody asks you, hey, you have this kind of game, will you play it in long run to make money? And the answer will be yes. Okay. The game that you don't want to play, or you don't want to play in long run, are the games where expected value is negative for you. Okay. Now that's for px. Next, how about the x squared? And then after that, we will compute the px squared. Yeah, because we need to find the variance to get the standard deviation, right? I square it. This is 100. This is 1600. 100 squared is 10,000. 200 squared is 40,000. And negative 5 squared is 25. Not negative 25. Not negative 25. It's negative 5 being squared is positive 25. Then multiply by the corresponding probability, that 100 times 10 is 1,000. 1600 times 4 is 6,400. 10,000 times 1 is 10,000. 40,000 times 10, that's 400,000. Oh, that's the one that you are actually chasing when you play this game. And 95 times 25 is 2375. Now then we add all these numbers. I get 419,775 over 220. Now then the variance of x will be 419,775 over 220 minus 1885 over 220 being squared. Where do you get that, Thomas? Well, the variance is the last number minus the middle number squared. If you remember my long time ago notation, I usually mark it this way. The first number times the last number minus the middle square. Okay? Divided by the first number square. But the first number is 1, so you basically end up with this guy minus the square of this. Okay? Now then I will use calculator from here. (1885) over 220. I square it and then subtract from 419,775 minus 220. Why I get negative number? Not supposed to. Not supposed to get a negative number, but why I get negative number? I punch it wrong. I'm sorry. 1885 over 220. I square it, and then 419,775 over 220 minus that thing squared. So I get 1834.65444. Now then the standard deviation of this random variable will be the square root of that number. Which is 42.83287. Okay, that's a long question, right? That's a long question. That's a long question. But it's worth 20 points, 1/5 of the test. So you better know how to do this. Okay, now this is for fall 20. What I plan to do after this, I will do a little bit. I don't think I will do all. From spring 20. Let me take a look on the question I asked you to do. Give me a second. So from our discussion board last time, I asked you to pay attention to fall. Oh no, I didn't ask you to do fall 20. So I already did that basically for free. But somehow I think my fall 20 and spring 20 are the same questions. So my fall 20 and spring 20 are the same question. Let me check. My spring 20. Yeah, as I remember, I did not change the question. Yeah, this is my spring 20. Yeah, exactly the same questions. Yes, yeah, spring 20. Yeah, exactly the same question. I think I changed the ordering. Yeah, so yeah, I changed the ordering. This is the last question. Yeah, but they have only 4. Oh no, it's slightly different. My number 8 is different. My number 8 is different. Okay, let me check for the rest, okay, so that I can adjust it. And I will give you the copy of this fall 20. Oh yeah, there are 2 different problems though. I'm in spring 20. In spring 20 number, their number 5 is different from that. Oh, you know what? It's a lot of difference. A lot of difference. Well, anyway, I already went over fall 20. So what I think I will do is then I post a blank test in our discussion board. Okay, I will post the blank test on the discussion board. Then after this, I will do spring 20, the one from spring 20. I will go over fall 20 and then we have the solution. Okay, then after this, I will go over spring 20. Okay, so if you take a look on our previous discussion from Monday, you will see I gave you that file, spring 20. Okay, spring 20. Okay, let me put it on here. So I'm done with this fall 20. Oh, I didn't realize that I didn't give that file to you. Well, anyway, and you have something to study from, right? Okay, now let's insert the one from spring 20. Give me a second. Oh yeah, now I remember. Yeah, I changed the question. Now this is 4 pages. This spring 20 is 4 pages, but it's kind of tight. It's kind of tight. We have smaller space to work on. And after that spring semester, remember spring 20 was the first time we actually, that semester we went online, right? Okay, and I didn't realize how important it is to give students more space. Okay, now right now it's 5:40. Let me take a break. I come back at 5:50 and we will work on this. Yeah, I give myself a little break. Okay, let me continue. It's not 5:50 yet, but let me just start. This is from spring 20 test 2. I really thought that I gave the same test, but it turns out it's not. Okay, but very similar, I believe. Like number 1 here, we have 4 main blood groups. There are actually a lot more than this, though. There are actually a lot more than this, but the main groups are these. Okay, now of 50 people, find the expected number of people have a positive. The number of people, the number of trials, 50. The probability of a positive is 34%. So the expected value will be 50 times 0.34. That's 17. Part B, of 60 people, find the standard deviation. Number of people have B negative. The proportion of having B negative is 2%. That's 0.02. So the variance will be 60 times P times 1 minus P. That's 0.98. Okay, the Q, which is 1 minus P, is 1 minus 0.02. That's 0.98. Okay, so when I multiply, I get 1.176. And then the standard deviation, therefore, is the square root of that number. Which is 1.084435. That's 4. Now, part C, find the probability that of 10 people, so n equals to 10, at least half of them have AB positive. What is the proportion of people have AB positive? What? Only 3%? That's 3%. That's 0.03. Now, what is the probability at least half of them has AB positive? Probability that number of people with AB positive is at least 5, right? At least half of them, at least half of that 10 people, that's at least 5. That's the complement of probability that the number of people having AB positive to be at most 4. That's 1 minus binom CDF 10, 0.034. Oh, that's 0.9999946. That's 0.000054. Now, if you round it to 5 decimal places, I believe I'm okay if you make it 0.00001. Yeah, if you make it 5 decimal places. Part D, find the probability of any of 10 people has A negative. Again, the n equals to 10, but the one we want to look at right now is the A negative. That's 6%. Okay, so the probability that the number of people having A negative is at least 1. That is 1 minus probability that the number of people with A negative equals to 0. That's 1 minus binom PDF 10, 0.060. Get 1 minus 0.538615. That's 0.46138. Part E, of 60 people, find the usual interval for number of people having B negative. The proportion of B negative is 2%. So the mean will be n times P. That's 1.2. And then the variance is 60 times 0.02 times 0.98. That's the variance. I somehow feel like, oh yeah, that's the, it happens to be the same to part B again. No, I didn't purposely do that though. That's 1.176. So the standard deviation will be square root of that, 1.176, which is 1.08444. Now then the lower fence, upper fence, that's 1.2 minus 2 times 1.08444. The upper fence will be 1.2 plus 2 times the same number. Top one, I get negative 0.96888. And the next one, I get 3.36888. Oh, okay, so the usual interval will be from negative 0.96888. So among these 60 people, if you don't get anybody with B negative, that's usual, that's okay. And it is still usual if you only get up to 3. Once you get 4 people with B negative, that's very, it's unusual already. Not very, but quite unusual already. Okay, now let's go on. Number 2. Hyperbole lottery draws 4 regular numbers from 1 to 50 and 2 hyperbole numbers from 1 to 20. So we have from 50, you will choose 4. From that 20, you will choose 2. Okay, now part A, find the probability of selecting correctly selecting one hyperbole number only. So the one correct, only one hyperbole. So of these 20 here, there are 2 correct hyperbole, you select only one. Only one of them correct. The other hyperbole, the wrong, you need to select one from those 18 wrong one. Now for the regular one, there are 50 numbers. You need to select 4 of them correct, which means 46 wrong, right? But for us to get only one hyperbole number correct means the regular number are all wrong. So that's what it looks like. Okay, I believe we did this problem in fall 20, exactly the same problem. Yeah, exactly the same problem. So the probability of getting no regular and one hyperbole correct will be 4 choose 0 times 46 choose 4 over 50 choose 4 times from the second box 2 choose 1 times 18 choose 1 over 20 choose 2. Okay, now here I say that just use notation. You don't need to compute into decimal, right? So just leave it like that. You can compute it. I don't mind. And actually, I don't care. What I care is I see this. Okay. Now, if you give me numbers after that, I put question mark, but I don't even check that. I wonder why you want to do that. Okay. Yeah, I will check your ability in computing those notations in other question. Now, part B, what is the probability of selecting 2 regular and 2 hyperbole correct? So you do the setup again of 50 regular numbers, 4 of them correct, 46 of them wrong. From 20 hyperbole, 2 of them correct, 18 of them wrong. You want to select 2 correct from the regular, which means the other 2 is incorrect. And both hyperbole correct, which means nothing selected from the wrong one. And this will be 4 choose 2 times 46 choose 2 over 50 choose 4 times 2 choose 2 times 18 choose 0 over 20 choose 2. That's for number 2. Let's go on. Number 3. The following lists the probability distribution of X, the number of times a student absent in twice a week class. Now, it's the outcome supposed to be 0, 1, 2 only. Yeah, the outcome supposed to be 0, 1, 2 only. But I have seen an instructor actually do this. That for each meeting, it happens to be a long meeting, like 2.5 hours. So that instructor says, if you miss 1 hour, that will be 1 absent. If you miss more than 2 hours, that will be 2 absences for that one day. Okay, so the person who missed 1 here, that will be missing, let's say, missing 1 hour instead. Okay, and if somebody end up missing 4 hours, it means that person missed 1 whole week. And that also means that student will be excluded. Okay, now then, extend to find the mean and standard deviation. Let's make sure that this is a probability distribution first, that they need to add up to 1. Right? Now, what is this guy here? Let's call that question mark, such that 0.30 plus 0.45 plus question mark plus 0.03 equals to 1. 0.78 plus what equals to 1? That is 1 minus 0.78. That's 0.22. Now, once you are done with that, then you can extend it. Px, this is 0, this is 0.45, 0.22, 0.09, which when I add, I get 0.76. So the expected number of absence a student have is 0.76. Per week, 0.76. So let's say in 4 weeks, I expect that person miss 2 hours. Okay, or yeah, that's my interpretation here. Twice a week, up to 4, right? Okay, now then x squared, this is 0.149, and px squared is p times 0, that's 0. P times 1, that's 0.45. 0.22 times 4 is 0.88. 0.03 times 9, 0.27. 16, oh, that's 1.6. So the variance of x will be 1.60 minus 0.76 squared. I get 1.0224. Therefore, the standard deviation is the square root of that number. It's 1.01114. Okay, so that's for number 3. Let's see number 4. A box contains 9 identical marbles except in colors. We have 4 green, 3 yellow, and 2 red. Now, 3 marbles are selected at random or without replacement. So it is not binomial. It is not binomial. Find the probability of selecting any green, at least one green. That's 1 minus probability of getting no green. Okay, so the way we look at the box now is 4 green and 5 not green. That's how we look at the box right now. Okay, now what is the probability you get no green? So nothing from here. So how many from not green? We select 3 marbles, right? We select 3 marbles. So 3 of them not green such that none of them green. This will be 1 minus 4 choose 0 times 5 choose 3 over 9 choose 3. That's 1 minus 1 times 10 over 3, 4, 120 times 9 combination 3 is 84. So that's 1 minus 10 over 84. That's 74 over 84. I can actually just make it decimal. That's 0.88095. That's for part A. Now part B. 3 marbles are now selected at random, 1 at a time with replacement. Find the probability of getting 2 yellow first and then a red marble, but it is with replacement. Okay, so we have 4 green, 3 yellow, and then 2 red, right? Okay, now what is the probability of getting yellow and then red? It is with replacement, means you put it back. The probability you get yellow first is 3 out of 9. Probability to get yellow again is still 3 over 9. Remember you replace that, right? Times the probability of getting a red marble, that will be 2 over 9. It is with replacement, right? You put it back. So you will always have 9 marbles stays in the box. And from here, I cancel one of the 9. That will be 2 over 81. Or simply, you can just leave it like that though. Yeah, you can just leave it like that. It's the simplest form anyway. That's 0.02469. Part C. 3 marbles are selected at random with replacement. Oh, part B, we cannot do it with binomial. We cannot do it with binomial because the order is important. Now, part C here, the question is you have 3 marbles with replacement. What is the probability of getting 1 red regardless the order? So we have 2 red and 7 not red. Okay, and we do it with replacement. So it forms a binomial distribution. Okay, that would be binom PDF. The number of trials is 3. The probability of getting a red for each trial is 2/9. How do you get that 2/9? There are only 2 out of 9 red. There are only 2 reds out of 9 marbles. And then you need 1 here. Probability notation, calculator notation, then the calculator result. I get 0.40329. That's for part C. Part D. Construct the probability distribution of the number of yellow marbles selected in procedure of selecting 3 marbles without replacement. So let X be number of yellow marbles selected. Now this X can be no yellow, maybe 1 yellow, 2 yellow, 3 yellow at most. It has 3 yellows, but the reason it is at most 3 is also because you only select 3 marbles without replacement, right? So you may have at most 3 yellow marbles. Now then let's compute the probability. Probability that X equals to 0 is what? Probability that X equals to 1 is what? Probability that X equals to 2 is what? Okay, but the configuration will be, we have a box with 3 yellow and the others not yellow. Now then, the probability to have no yellow means from those 3 yellow select nothing, from the non-yellow select all 3. That's 1 times 20 over 9 choose 3 is what again? 84. This is 20 over 84. How about probability that one of them yellow? From those 3 yellow, you choose 1. Times 6 not yellow, choose 2, because the total is 3, right? 9 choose 3. So that will be 3 times 5 is 15 over 84. That's 45 over 84. That's more than half, huh? So the probability that we get 1 yellow, exactly 1 yellow, is at least, it's more than 50%. I'm surprised with that result too. Probability that 2 yellow will be 3 yellow choose 2, 6 not yellow choose 1 over 9 choose 3. That's 3 times 6 over 84. That is 18 over 84. And probability that we get 3 yellows will be 3 choose 3 times 6 choose 0 over 9 choose 3. That's 1 times 1 over 84. That's 1 over 84. Now then the probability distributions will be is 20 over 84. Don't make it decimal. It's a lot harder to compute actually if you make it decimal. Just leave them in fraction. If you can simplify with common denominator, that would be great. Okay, but at least right now they already have common denominator. So if you add them, you just add the numerator, right? Okay, when I add this, I get 83, 84, 84 over 84. So it is now a probability distribution. That's how I'm done with my page 2. We did this similar question before, okay? Yeah, we did this similar question before. So you know you will have this kind of question in your test. Number 5. I will finish this problem number 5, and then I will take a little more rest, maybe like around 5-10 minutes. Then I come back and finish number 6, 7, 8. Number 5, probability of A is 0.7. Probability of A given B is 0.5. So they are not independent. Okay, what is the probability of the intersection? Hold on. Let's see what's the formula for this. Probability of A given B is probability of D intersection over probability of B. But I don't have probability of B. In other words, I don't get this, I don't have this. So I cannot do this problem to find the intersection using this one formula. Probability of B given A is probability of D intersection over probability of A. Oh, okay. So this is what I need to know for part A, but I already have these two numbers. So I will use that formula. I will use that formula. So probability of B given A is equal to probability of D intersection over probability of A. Right? I plug in numbers. Probability of B given A is 0.4 equals to probability of D intersection over probability of A 0.7. So probability of D intersection A and B is you multiply both sides by 0.7. That's 0.28. How about the probability of B? Now I already have this guy and I already have this guy in the question. I can use that to get this probability of B. So I have to be honest, your algebra has to be still good, okay? Simply because they don't require that from you doesn't mean you don't need it at all. To say that you pass statistics class, it implies that you know some algebra. Okay, A given B is 0.5. It's 0.28 over probability of B. So 0.5 times probability of B, I multiply both sides by probability of B, I get 0.28. So probability of B is 0.28 over 0.5. That is 0.56. Part C. What is the probability of the union? Oh, this one, we have probability of A that's given plus probability of B that we get from part B minus probability of D intersection that we get from part A. I get 0.98. Now, how about probability of not A but B? That's probability of B minus probability of D intersection. 0.56 minus 0.28, that is still 0.28. So probability of B given not A is probability of not A and but B over probability of not A. That is 0.28 from part D over probability of not A. That's 1 minus 0.7. So 28 over 30 is 0.93333. Okay, number 6. I will take a break right now, but when we come back, this question is quite similar to what we had earlier. In fact, we still get from 420, we still have 5 Sprite, 4 Coke, and 3 Fanta, but the payout is different. $10 if all Sprite, $30 instead of 40 for all Coke, $100 for all Fanta, and no $200 for Sprite, Coke, Fanta in that order, remember? Okay, and the player loses $1 otherwise. In that question, we lost $5 if you get something else. Okay, so I actually do expect you can do it yourself. It's way too similar question. Okay, but to be honest with you, I can give you a very similar test and you still bomb it if you don't study. Okay, so if I were you, if you already watched from the beginning of this video, try to do it on your own. I will take a 10 minutes break and I will pause it. Okay, but what I want you to do, if you listen up to this point, try to do it on your own first. Okay, and then you play that again later on because I will pause it, right? Okay, you pause it also. Try to do it on your own, and then later on you run the video again to see how we will do that. Okay. Okay, let's continue. Okay, you should try that first. Okay, because I always have this kind of question also. Let X be the payout. Now here, X can be $10, $30, $100, or losing $1. That's a pretty good party game. If you have a party and just to make the air kind of exciting, then you play little game here and there, right? Okay, and if people can do math and they see, oh, the expected value is actually positive, then they will join the party. They will join the game. In fact, they will fight to get in turn. Now let's compute the probability. Okay, probability that the payout is 10, which means the probability that all Sprite, we have 5 Sprite and 7 not Sprite. You need to select 3 from here and nothing from here. That will be 5 choose 3 times 7 choose 0 over 12 choose 3. That's 10 times 1 over 12 choose 3 is what? I think it's 84. 220. 10 over 220. Probability that the payout is 30 is the same to probability that all of them Coke. That's, let's see, the breakup for Coke. There are 4 Coke, means the other 8 are not Coke, right? So that's 4 choose 3 times 8 choose 0 over 12 choose 3. 4 choose 3 is 4. 8 choose 0 is 1 over 220. That's 4 over 220. Probability that the payout is 100. That's when probability that all of them Fanta. There are 3 Fanta and 9 not Fanta. You select 3 from here, means nothing from here. That's 3 choose 3 times 9 choose 0 over 12 choose 3. That's 1 times 1 over 220. That's 1 over 220. Now that's the total. If you add this, then you will get the probability of winning something, which is 15 out of 25. Now, what about the probability of losing $1? That's the probability of otherwise. That's 1 minus probability of winning something. That is 1 minus 10 over 220 plus 4 over 220 plus 1 over 220. That's 1 minus 15 over 220. You do LCD, boom, 205 over 220. That's the probability of losing $1. $1. Now then, construct the probability distribution. X will be either 10 or 30 or 100 or -1, right? With probability computed earlier, that's 10 over 220, 4 over 220, 1 over 220, 205 over 220. The total is 220 over 220, which is 1. Now then the first extension px, that's 100 over 220, 120 over 220, 100 over 220, -205 over 220. I get 105 over 220. Positive. It's still positive. So yes, in the long run, this game will be a winning game for the player, which is not common if you go to casino. I mean, if you go to casino, you expect to lose. The expectation for you will be a negative number. So on average, a player will win $0.47727 per game. Now we need to find the standard deviation. So we need to find the variance. So I need to do the second extension. It's x squared. This is px squared. So x is 10, squared it becomes 100. 30 squared becomes 900. 100 squared becomes 10,000. And 1 squared is just 1. Multiply by x. This is multiplied by the probability. multiply by the probability, multiply by the probability, multiply by the probability. So 1,000 plus 3,600 plus 10,000 plus 205, I get 14,805 over 220. So the variance will be 14,805 over 220 minus 105 over 220 being squared. Okay, and I use my calculator. You need to know how to use your calculator for this though. I get 67.067665. So the standard deviation will be the square root of that number, which is 8.18949. That's the standard deviation. Yeah, actually with this number later on you will see winning $10 even though it's less than 5% is actually not that unusual. It's actually quite okay. Yeah, unless I make miscomputation though, but I don't think so. Yeah, let me check that again. Let me check my computation again. Okay, but I don't think I get it wrong. Yeah, I don't think I get it wrong. No. I think I make a miscomputation. So 100 plus 120 plus 100 minus 205. That's 115. So this number is supposed to be 115. The one here, this one, supposed to be 115 over 220. Okay, so 115 here. So I need to update this. I need to change this, change this, change this, change this. Okay, 115 over 220. That's 0.52273. And then 14805 over 220 subtracted by that number, I get 67.02221. The square root of that, not that much different. That's 8.1618671. Okay. Now remember earlier I said that it's not unusual to win $10 even though the probability is less than 5%. Okay, because when I look at the usual interval, the usual interval actually includes that 10. Okay, so if I were you, first, this game has positive expectation. I will definitely play that. Okay, and the standard deviation is actually quite big. Okay, so it's not that unusual for us to get uh, the payout of 10, because the usual interval includes 10. The usual interval does not include 30 and 100, however. Okay, so I will be smiling if I win $10. Okay, I will be laughing if I get $30. And losing $1, I play that. Yeah, I play that. Okay. That's for the end of page 3. Let's go on to page 4. The following Venn diagram describes the number of elements in ABC. Let's find out how many elements in there first. That will be 9 plus 7 plus 2 plus 10 plus 1 plus 2 plus 3 plus 6. 22, that's 40. Oh, is it the same table we have? At least one from, suppose 4 elements are randomly selected without replacement. So they tell us in explicitly without replacement, find the probability that at least one of them from A. So probability that the number of A is at least 1. How many A's, by the way? That's 7 plus 2 plus 2 plus 1, that's 12. So this is 1 minus probability that no A at all, right? But there are 12 A's, which means 28 not A's. A total of 40, right? Now, what is the probability you get nothing from here, which means 4 from there? It's 1 minus 12, choose 0 times 28, choose 4, over 40, choose 4. I think, yeah, I say just use notation. You don't need to compute into decimal, so I will just leave it like that. What is the probability? Only one of them B, exactly one B. So how many B's? The number of element in B's will be 1 plus 2 plus 3 plus 6. Oh, there are 12 again. Okay, what a coincidence. Then there are 12 B's and therefore 28 not B's. You select 4 elements, right? If one of them from B, then how many not B? Of 4 elements, one of them B, then 3 of them not B. The probability becomes 12 choose 1 times 28 choose 3 over 40 choose 4. The probability for part C, the first 2 are from C. So how many C's? That's 2 plus 2 plus 3 plus 10, that's 17. So there are 17 in C, 23 not in C. But here the order is important, so we cannot use combination. Okay, we can do it one by one though. The first 2 are C. What is the probability the first one is from C? 17 over 40. The probability the second one also from C. The probability the third one not from C. And the fourth one also not from C. Okay, now we can also do it this way though. If you see that it's like, hey, do you know what? I can use permutation. That's 17 permutes 2 times 23 permutes 2 over 40 permutes 4. Yeah, these numbers will give you exactly the same number up there. Okay, now finally, number 8. At a grocery store, the number of customers arriving at the checkout line follows Poisson distribution with the rate of, so let X be number of customers at checkout, X is Poisson distributed with average 1.7 for 5 minutes. Okay. What is the probability to have at most 4 arrivals in 5 minutes? Probability that X is at most 4. That would be Poisson CDF. It's already 5 minutes, right? Period. Poisson CDF. The average 1.7 up to 4. I get 0.970385, so 39. What is the probability that you have at least 20 arrival in 5 minutes? Oh wow, the average is 1.7, right? If you have all of a sudden at least 20 people going in 5 minutes period, I believe something really different. You suddenly sell something different. Some word goes out that people attracted to your grocery store, right? Because the probability, let's compute the probability. You will see the probability is extremely small. That's 1 minus probability that X is at most 19. Right? The complement of at least 20 is at most 19. That is 1 minus Poisson CDF. $1.7. That's because that's the average for 5 minutes, right? Up to 20. I'm sorry, it should be 19 there, not 20. Should be 19 here, right? 19. But when I compute using my calculator, it's 1 anyway. So the probability that you have at least 20 customers suddenly come in the last 5 minutes, in the next 5 minutes, that's basically 0. That's basically 0. The probability is so small that even our calculator will just call that straight 0, not even by approximation. So if it does really happen, then something goes, I think I should say something goes right about how you sell stuff or what you sell. Okay, now part C, the last question. Find the probability that no arrival in the next 2 minutes. Now the thing is your average is for 5 minutes, right? Your average is 1.7 for 5 minutes. If you divide, that will be 1.7 divided by 5, 0.34 for 1 minute. Okay, so the average will be 0.34 times 2 for 2 minute period. So what is the probability that no arrival in 2 minutes? That will be Poisson PDF 0.32 times, I'm sorry, 0.34 times 2, or you can just say 0.68 right away, comma 0. Probability 0.50662. Okay, now that's the probability for not having anybody come to the checkout in the next 2 minutes. And that's the end of this Spring 20 Test 2 solutions. So with you, I do 2 previous tests. I hope you really study, okay? I hope you really study. Now, the second test, the Spring 20 here, I realized that I ran it faster. Okay, but that's because I'm afraid that I run out of time. Okay, and some of them actually repeat from fall 20. So just stop the recording if you need more time to think about it. Okay, now on this Friday, I will do 2 different sets of test 2 with my East LA College students, and I will make the recording available for you. I will post that on maybe on the announcement board, not on the discussion board. Okay, I will say announcement, test 2 review. Okay, that's for today. See you then. How many days from now? 12 days from now. Bye-bye.